Hello, in this modern OpenGL tutorial, we're going to be covering lighting maps. So what is a lighting map? Well, for starters, I've got a couple of extra images here from the previous project. Got container 2, which is essentially just a texture of a crate. And we got this specular image. This will seem familiar in terms of you look at it, you know what it is. This, not so much, especially considering both of these are meant to be applied to the same surface, the same image. So how are these used? Well, in the real world, if you have, let's say, a crate, for example, that is partly metal, partly wood, the wooden parts of it will react differently to the light compared to the metal parts of it. It might sound obvious, but in OpenGL or any other sort of 3D graphics API, it doesn't have a concept of wood or metal or plastic or anything else. And as a result, we need to program that in. We need to use other techniques to help illustrate that visually, because the wood would be less shiny compared to the metal part of the crate. And this specular image is created so certain aspects of it, as you see, the sort of the lighter areas will react differently to the darker areas of the image. I think you can guess how differently it will react, considering this is metal and the inside of the middle part of it is meant to be wood. So that's essentially a sort of overview of what lighting maps are. Feel free to use these images from our GitHub page. Our source code will also be there. Plus, if you Google lighting maps, you get a bunch of information. You can create them in tools, in various tools. You can use Maya. Photoshop will be a good one to combine them with. You can get plugins. This is a whole field in itself. I'm just simplifying it, and I've got these two images. So without further ado, let's get down to the coding aspect. So what you want to do is go to the lighting vertex shader. You need to do a few modifications to this because we removed the ability to apply textures because we weren't doing that for the last couple of videos. So we need to add that back in. So layout, location, let me zoom in for you so it's easier to see. So there we go. Layout location equals to in. This is just going to be a vector 2 simply because a texture, an image, only has an x and a y coordinate system. So text coords semicolon, and for the output vector we also need to do the same. So out vec2 text coords, not text coords, never text and OpenGL. So if we go down here, for the position, that remains the same. We're not going to be modifying the position because having a lighting map system doesn't affect the position. The frag position still is not modified. The normal, that isn't changed either. The only thing that we need to do now is do text coords equals the value that was input, which is text coords a semicolon. Now we need to do a modification to the fragment shader. So for this, first of all, what we want to do is we just I'm just looking at this. What do we need to change? So let's just zoom in so it's easier to see. Yeah, here we go. So for the struct material, we're going to actually remove the ambient. We don't want just sort of like a general color to it because that's going to be based on the actual texture itself. So remove that. Diffuse specular, that is all fine. Actually, we need to change this quite a bit because we're going to be using 2D based stuff instead of vector 3. So honestly, it's best if we just delete the contents and just recode it. So it's sampler 2D diffuse sampler 2D specular, and this is the specular light map that you saw, which had the light part and the dark part on it. Float, shininess. Shininess is always important. Shininess. For the light, position, ambient, diffuse, specular, that's all good. We're not modifying that in any shape or form. The vector for color, that's all good. For the input, we also need the texture coordinates, so we do in vec2, not int, in vec2, text coords. Let's just scroll down a little bit. We can leave these because we will be using all of these bad boys. So for the ambient, light.ambient times by material.ambient, that needs to change slightly because we are using a texture. So what we need to do is just get rid of this. For vec3, inside of here, we want to specify texture. Inside of this method, we want to do material dot diffuse text coords. That's all good. Now for the diffuse, normalize normal, that's all good. We're normalizing the difference between the light position and the frag position. That's still going to stay the same. For the difference, max dot normal light direction, that's all good. And for the diffuse part of the final calculation, this needs to change slightly, simply because we are using what's it called, textures now. So what we're going to do is just get rid of this. So I'm going to do light.diffuse.diff times by vec3 texture material dot diffuse text coords. Okay, that's all good. Let's go down to specular now. Normalizing the difference between the view position and the fragment position, that's all good. The reflection direction is all good as well. And this looks all rosy to me. Just need to change this slightly because we are using a texture now. So we need to do light.specular times by spec. So just calculated right here. Times by vec3 texture. I think you can guess what's going to go in here. Material.specular. And we're specifying the texture coordinates. That's all good. For the result, we don't actually need to specify. Actually, that's fine. So we've got the result equals ambient plus diffuse plus specular, and we are specifying the result into here. That's all good. Let me just scroll out now. I just want to check one thing. Yeah, we are recording. For some reason, I had a funny feeling that we weren't recording. Well, you wouldn't hear this if we weren't. So we're all done with the shaders now. We can actually get to the main.cpp. The first thing we will need to change is the vertices. At the moment, we got the position. Let me just do square selection. We got position, and then we got the normals as well. We also need to specify the texture coordinates because we now are using a texture. Got these right here instead of putting these in, which will take a bit of time. Very simple stuff. We've covered what these essentially are in a previous video, so feel free to check them out. So simple stuff, normal, positions, and texture coordinates. So now what we want to do is just scroll down a bit, keep scrolling down till we get to where we're binding the vertex and we're creating the vertex pointers, because we have added a texture system into it again. We need to modify these slightly. So we got the vertex array, that's fine. Generating the buffer, that's fine. For binding, we also need to bind the buffer now, which actually, no, my bad, we've already done it. We need to do the gr buffer date, which is all good, and that's looking pretty solid to me. So now in the vertex attribute pointer, we need to modify this slightly. We got 0, 3, that's fine. But because we got 8 pieces of information in our vertices, or for each row, we need to change this to an 8. So good. We also need to change this to an 8. Leave that as 3, that isn't a problem. What we also need to do is just duplicate this. Now we need to do it for the texture attribute. So we're going to do texture attribute. So GL vertex attribute pointer. We need to put 2, and because we only got 2 pieces of information, the X and the Y. 8 pieces of information in each one of our rows, and we're moving into it by 6 because we don't concern ourselves with the first few pieces of information. Set this to 2. Still unbinding the vertex array object. Let's take a look at the lighting. I feel like there's something we need to change in this lighting code. So what do we need? So we got the generating the vertex array, that's all good. Binding vertex arrays, yep, that's there as well. We are doing the, just feel like that we're missing something. So yeah, let me just go through it again. Vertex arrays, bind buffer, that's looking all good. So we're binding the buffer, GL array buffer VBO 0, 3. Here we go. This needs to be an 8 because again we've got 8 pieces of information. GL enable vertex attribute array. That, yeah, that's looking pretty solid to me. So what we're going to do, you don't have to necessarily do this before we do the projection, but we're just going to load the textures, and we're going to create the diffuse and the specular map as well, essentially just loading 2 different textures. We've covered this before, so I'm not going to be explaining it too much, or if at all. Feel free to check out the textures tutorial for more information. So let me zoom in. So we've got GL U int diffuse map, and this is specular map. I'm going to do GL gen textures, and for the size we're going to put 1, and for the pointer I'm going to put ampersand diffuse map. I can copy and paste this to save some time. Just need to change this to specular. Now we need to create an int for the texture width and height. Texture height. Now we're going to do unsigned char. This is essentially going to be the data of our image, because if you ever try to open up an image in some sort of text editor, it's got a bunch of characters. This is essentially what this is going to be storing. So now we're going to do the diffuse map. Scroll down a bit. Diffuse map. We're going to do image equals soil underscore load underscore image. First of all, we need to specify the file name, so it's res/images /container2.png. For the width and the height, we just specify the width and the height that we created before. Because what this is doing is passing it in as a reference, and what it will do is actually modify these original variables right here. Let me scroll to the right slightly. For channels, put 0. For force channels, just put soil underscore load underscore RGB. Put a semicolon. Scroll over slightly. Oopsie daisy. And now we need to do GL bind texture. So for the target, it's just GL underscore texture underscore 2D. And now for the texture, we'll just specify diffuse map, because that's the one we're using at the moment. Now we need to do GL text image 2D. For the target, Again, it's just GL underscore texture 2D. For the level, for 0. For the internal format, this is just RGB because it's got no alpha. For the width, you just put texture, width, then texture, height. For the border, put 0. For the format, put GL underscore RGB. Really should scroll over now. And for the type, I'm going to put GL underscore unsigned byte. For the pixels, specify the image data, which is image. Put a semicolon. Now let's scroll over slightly. Now we're just going to generate the map. GL generate map. I'm going to put GL underscore texture 2D soil underscore free image data. I'm going to specify the image that we want to basically free. And now we just need to specify the texture parameters in terms of wrapping and the filtering. So we do GL text parameter, not text. I keep doing text. It should be GL text parameter. So GL text parameter I. And for the target, GL underscore texture 2D. For the name, or what we're modifying, it is the wrap for now. So texture underscore wrap underscore S G L underscore repeat. So let's just duplicate that. We just need to change this to a T. Copy and paste this. We can modify what we're essentially modifying to GL underscore texture underscore min filter, and this to GL underscore linear underscore map linear. I'll actually copy and paste this because there'll be less changes to do. I need to change this to mag and this to mip. This to nearest mip map nearest. So now that we've done that, what we're going to do is actually just duplicate all this code for the specular map, because it'll be a lot easier, because a lot of it's going to stay the same. So let's just change this comment to specular. We're obviously loading a different image now. We need to do container2 underscore specular. Still using the texture width and height parameters. Change this to specular. We've got GL texture 2D. This is still saying same. It's all good. We're just gonna sort of unbind the texture now. So we're gonna do GL bind texture. Target is GL underscore texture 2D. I'm gonna put a 0 here. And now we just need to set the texture units for the lighting shader. So we're gonna do lighting shader dot use, and in here I'm going to do GL uniform 1i. I'm going to specify GL get uniform location lighting shader dot program, and we just need to do material dot diffuse. This is all stuff that we did in the shader, so feel free to look at that again if you just need a quick reminder. Just put 0, and now we need to put 1 material dot specular. Yeah, we're all good now. We can actually start coding stuff within the loop. I'm gonna get rid of this because this was just changing the lighting. You know what, I'm gonna comment here. We could add it back in later. might be good to test it using that. It is quite cool to use it when you try and see how the lighting works. So we're going to be reusing quite a lot of the code here. So for the lighting shader.use, we're using the light.position, we're using view pause, that's all good. For the uniform 3F, light position location, so good. For the view position location, again, that's all good. And now we're gonna start changing some stuff up. So we're gonna set the lights properties. So what we're gonna do is just get rid of all of this, and we're gonna put GL uniform 3F. We'll fix all these errors like here in a moment. I'm gonna put GL get uniform location lighting shader.program, and we just need to specify the first aspect that we're modifying, which is the ambient, and we're just going to put some hard-coded values in here. 0.2f, let me just scroll over slightly. 0.2f, 0.2f, and 0.2f. Let's duplicate this. So we've got 3 instances of it. We need to change this to diffuse. Change this to specular. I'm going to modify these values slightly. I have 0.5, 0.5, and I think you guessed it, 0.5. It's going to be 1.0 now. 1.0. 1.0, and now let's have a look. The diffuse color and the ambient color, we're actually going to get rid of this as well. I'm going to get rid of, actually we'll get rid of this because a lot of it's going to be changing, so it's just easier if we just get rid of it. So now let's set the material properties. So GL uniform 1F. Now we just need to get the uniform location, lighting, shaded up program, and we just specify material dot shininess, put 32.0f. Let's show you what I put. So 32.0f. And now after that, we need to create the camera transformation, which we've already done. Let's scroll down, scroll down. So we got the model, view, and projection location. That's not changing. A lot of the time, that will just stay the same. Passing the attributes to the shader for the view location and the projection location. Again, that isn't changing whatsoever. Now we need to actually activate our textures and bind them. So what we'll do is GL active texture. I'm going to do GL underscore texture 0, GL bind texture, and we need GL underscore texture underscore 2D, and for the texture diffuse map, simple stuff. Or you can copy and paste this for the binding of the specular texture map. Change this to a 1, and now simply change this to specular. And now we're drawing the box. That shouldn't change one little bit. So for the lamp shader, let's have a look. Lamp shader looks all good. For the, well, what else we got? So where was we? I've sort of this. Okay, yeah, we got the lamp shader. Model view, projection location, that's all good. We're setting the matrices now. That, honestly, everything just looks a-okay to me. I think we're ready to run. How we deleted all the vertex arrays, yet we didn't create any more. So we should just be able to run this now, and it should work, or we hope it works. Okay, so we've got some sort of texture. Make sure there's no errors. Can I activate the console through here? No, I'm just going to do it through here. So view, debug area, activate console. It's got no errors, so that's good. You can look around. Got the light source there. Let me move around. As you can see, as we're moving, the lighting affects the shape in a different way. Because when we was looking at it head on, there wasn't much of a shine. There's a bit toward the top right. But as we're moving, it's realistically affecting our object. But as you can see, let me just go down slightly. It's only affecting the metal part. The wooden part is unaffected, which is fantastic. So if we get a little closer, let me actually get to the top. It's doing the same for every single side. Obviously the back, not really, because there's no light appearing there. So this is it. This is an awesome way of distinguishing between different materials, different materials on an object, so wood, metal, plastic, glass, that sort of stuff, and it creates a real cool effect. So I'm just going to end this, and I'm also going to, let me just minimize this because this is just, it's getting in the way. We want to go to, where was it, this light position. I'm going to run that now, just so you can see the light is moving around. As you can see, again, only the metal part of it is shining off, which is fantastic. Obviously, it depends on what sort of angle you're looking at the object from. That's how it is in real life. So that's it for lighting maps. If you have any questions, feel free to post them on our education platform, sonarlearning.co.uk. There'll be a link in the description. Along with that, there'll be another link to the source code from all of these videos in this series. These videos are based on the works of Learn, OpenGL.com and Open.gl. There'll be links in the description to those websites, and I'll recommend checking them out because we've tried to cover as much as possible, but those amazing websites cover what we're doing in more depth. They go over it line by line, even more in more depth than we do, and they have diagrams to accompany a lot of it. So in general, watching these videos are fantastic, but then going and having a look and reading about what we're doing is just going to enhance the experience of learning that little bit more. So, as usual, thank you for watching, and I hope you have a great day.